بسم الله الرحمن الرحيم. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقه قولي. صدق الله العظيم. Welcome students again to the subject engineering drawing. Today our topic is conic section, and this is week 6 and it's also our 6th lecture of this week. As I have told you this subject has no prerequisites. I'm your teacher, Engineer Kamar Zaman. All the helping materials including this lecture will be uploaded to the portal.sood.edu.pk. You can log into the portal.sood.edu.pk and can download all the helping materials as well as video lectures of the engineering drawing of your current semester. Coming towards the main topics, that is mainly we will see here conic sections and sub parts of this lecture. First of all, we will see the outlines of this lecture. In the outlines, there are three main topics. The first one is ellipse, the second one is hyperbola, and the third one is parabola. We will see the construction methods of these three shapes. That is ellipse, hyperbola, and parabola. The first one is ellipse. For the construction of an ellipse, we will see two methods. The first one is concentric circle method and the second one is basic locus method. In the concentric circle method, we will see that how an ellipse can be constructed using concentric circles. Concentric circle means they're drawing one circle and again the other circle and having the same midpoint, that is center of all the circle will be same. So such kind of circles are known as concentric circle. The other method that we will utilize for ellipse construction will be basic locus method. The second topic of our lecture will be hyperbola. Hyperbola, we will construct hyperbola by using coordinate system, and the second one we will use pressure volume diagram system, and the third one will be basic locus method, that is directrix focus method. On the other hand, we will also construct parabola, that is from the conic section. Here we will construct a parabola by rectangle method, the second method of tangents, and the third one will be basic locus directrix method, that is directrix and focus. Here we can see that basic locus method for ellipse, basic locus method for hyperbola, and basic locus method for parabola. This method is common for all of these shapes or conic sections. So coming towards ellipse, that what is an ellipse and how it can be constructed and what are the methods that it can be constructed. First of all, we will see the conic sections, that what is a conic section. So ellipse, parabola, and hyperbola are called conic sections. These are known as the conic sections, that is parabola, ellipse, and hyperbola, because of these curves appear on the surface of a cone when it is cut by some typical cutting planes. This sentence says that when a cone is cut by some typical planes, it gives us different shapes, that is ellipse, or it might be parabola, or it might be a hyperbola. Let's see that how it gives us these different conic sections. First of all, we will take a cone and then we will cut the cone in such a manner that side 1 and side 2, these sides are known as generators of the cone, are cut by a plane. You can see here that this one and this side is cut by a plane. So it will give us a shape like this one. This is known as a ellipse. Here you can see that ellipse has been formed. This is one is known as generator 1 and this second one is known as generator 2. The sides of the cone are known as generators. So here the line is passing from both of the generators, and by cutting the cone we will receive this kind of a shape, and this is known as ellipse. Now let's see the parabola, that what is parabola or how can it be achieved. So taking again the same cone, and the cone is cut along one generator, that is side 1, and from the base. But you can see here that the cutting plane line is parallel to the generator 2, that is the side number 2. So the line, that is cutting plane line, will be parallel to the side 2, will give us a parabola. Now let's see the shape that acquired from cutting of a cone is this one. So this is known as a parabola. On the other hand, let's see the hyperbola. In the hyperbolic shapes, we will take a uh, cone, and this cone is cut by a plane in such a manner that the cutting plane line will be parallel to axis of the cone. So here you can see that the cutting plane line is equal to or parallel to the axis of a cone. The generator number 1 has been cut down while the generator 2 is not touched. So the line, that is cutting plane line, is parallel um, to the axis of the cone. So this is the object, or this is the section which we have acquired is hyperbola. Let's see the common definition of ellipse, parabola, and hyperbola. These are the loci of points moving in a plane such that the ratio of its distances from a fixed point and a fixed line always remains constant. This definition says that these are the loci or locations along a line which, on the moving from a fixed point and a fixed line, will give the same ratio. This is known as fixed point, that is a focus, and this is known as a fixed line, this is known as a directrix. So the directrix is a fixed line, and the focus, that point is a fixed point, is known as a focus. So the location points moving in between them, that is from fixed point focus to line, will give us a same ratio or equal ratio or constant ratio. This is known as a eccentricity. Eccentricity for ellipse is less than 1, eccentricity for parabola will be equal to 1, and for hyperbola it's greater than 1. So what is eccentricity? Eccentricity is the ratio in between. This is a vertex, this is a directrix, and this is focus. So eccentricity is equal to VF divided by, for example, I will give here V point A. So this is VA. It is the ratio between VF and VA. So this is known as an eccentricity. The value remains constant means that, for example, a point is here. So the distance from, for example, this line has 20 centimeter or any unit 20, and the other one is 40. For the other one, here it is 30, the other line will be 60. So moving in such a manner. This line will be 40 and the other will be 80. So here you can see that 40 divided by 20 equal to 60 divided by 30, 80 divided by 40. All of them will give us a same value, that is 2. So this is the ratio coming from all of these position will be same. So this is known as eccentricity. So the value that we will achieve from the ratio of these positions, if the value lies less than 1 for eccentricity, then it will give us a ellipse is greater than or if equal to 1, then it will give a parabola, or if greater than 1, then it will give a hyperbolic shape. We will see also the related problems with ellipse, parabola and hyperbola later on. It is the second definition of an ellipse. It is a locus of point moving in a plane such that the sum of its distances from two fixed points always remains constant, and this sum equals to the length of a major axis. These two fixed points are focus 1 and focus 2. In this uh, conic section, that is for an ellipse, here is a major axis, and from the major axis there are two fixed points that are known as focus. So on the major axis, focus 1 and focus 2 are given, and from these fixed positions the lengths can be taken. Same from focus 1. Coming towards the construction of a ellipse using concentric circle method, here it's stated that draw an ellipse by concentric circle method if major axis is 100 millimeter and minor axis is 70 millimeter. So this we will first draw a line that is major axis of 100 millimeter length, and the other axis, that is minor axis, of 70 millimeter length. We will name it as ABCD. First we will draw a circle of radius 35 millimeter or diameter 70 millimeter, and the other circle that is 100 millimeter. And now we will draw equal 12 lines, or we will divide the circle, these both circles, in 12 equal parts. That is, here you can see part 1, part 2, second line, third line, fourth line, fifth line, sixth line. Here you can see that both the circles have been divided. After drawing the lines or dividing it in equal 12 parts, we will draw perpendicular lines here like this from all of these and so on. Here you can also see from all these points we will draw perpendicular lines. And now parallel to the major axis. So these are the lines that we will draw parallel to the major axis. Now you can see that these lines have been coincide with each others at a specific point, and I have marked them. Now you can join these points by a line, and now you can see that we have acquired an eye shape. So this is known as a ellipse. Now let's see the other method of construction of an ellipse, that how we can construct ellipse by directrix focus method. So for the directrix focus method, we will need eccentricity and a fixed point from a directrix length. Here, let's start from the problem. Here it says that point F is 50 millimeter from a line AB. Point P is moving in a plane such that the ratio of its distance from F and AB remains constant, and it equals to 2 divided by 3. Draw locus of point P. So here you can see the eccentricity is 2 divided by 3, and I have told you if the eccentricity value is less than 1, it will give us a ellipse. Here this is the constant line, and this line is known as a directrix. From AB line, draw a perpendicular other line. This is and draw a fixed point on the that line, that is 50 millimeter away from the directrix. Now divide the line in 5 equal parts. You can see here that I have divided the line in 5 equal parts, 1, 2, 3, 4, 5. Take the second position from, or second part from the focus, that is 1, 2. This one is second part or position or division from the focus, because here from the eccentricity value you can see that 2 divided by 3. So the distance or the points from the focus is 2, while from the directrix is 3. So here 1, 2, you can see 1, 2, 0, 1, 2, and on the other side 1, 2, and 3. So I will take the vertex here on point or position 2. Now draw a line anywhere on the left side of focus. Take it as 30 millimeter, and this one is 45 millimeter. Again draw another line, and in the same manner draw the line. These lines are touching the parallel lines, or on some position. Connect these points by a pencil or a pen. You will have a shape like this. This is known as a ellipse. So this is the construction method for an ellipse. Now coming towards the other conic section, that is parabola. For parabola, we will first see the rectangle method. So a problem is given: a ball thrown in an air attains 100 meter height and covers a horizontal distance 150 meter on ground. Draw the path of the ball. In the statement or in the problem, it's stated that a ball is thrown in an air 100 meter above and it covers a horizontal distance 150 meter. So draw its projectile motion by the help of a rectangle method. So here you can see that a rectangle is drawn. A rectangle is a geometrical shape that having opposite sides equal in length, but not all your sides will be equal. Divide the rectangle in 2 equal parts, and again divide the sides in equal parts, like this one: 1, 2, 3, 4, 5, 6, and other on the bottom 1, 2, 3, 4, 5, 6. You can see, and divide the same other right hand side in equal parts, that is 6 parts, and bottom also in 6 parts. Now erect perpendicular lines from the bottom 1, 2, 3, 4, 5, 6, like this, and it will touch the other lines on specific positions, like this one. Now can see that these lines have been intersect each other. Here you can see that the points have been acquired. Now draw a line passing through these points, and this is known as a parabola that we have achieved. The other method for parabolic construction is tangent method. So let's see that what is tangent method. First of all, we will draw a triangle. For parabola, a triangle has been drawn. Let's see A, B, C, and I will divide both sides in equal parts, that is 14 parts from A to C, and again 14 parts from C to B. Now we will join the opposite sides with each others, the opposite points with each others. It will be like this one: 1 to 1, 2 from 2, 3 to 3, 4 to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Now you can see that we have achieved this arc, and this arc can be extended, or this arc can be seen as a parabola. So here this is a parabola that we have achieved by the method of tangents. Again, like an ellipse, we will see the directrix focus method for the parabola construction. I have told you that for the parabola, the eccentricity value will be equal to 1. The question is same like that of an ellipse. Point F is 50 millimeter from a vertical straight line AB. Draw a locus of point P moving in a plane such that it always remains equidistant from point F and line AB. Draw a vertical straight line, that is directrix AB, and here there will be a focus, a fixed point, and the eccentricity value will be 1. If eccentricity value is 1, then the distance in between VF and VA will always be equal. So therefore we are receiving the same eccentricity value, that is 1. Now draw any draw lines on any points but in equal parts, that is 1, 2, 3, 4. And like here you can see 1, 2, 3, 4. On the other side you can also draw same lines from focus, keeping the compass from focus and extend it towards 1, 2, 3, 4, 5. So first of all I will extend the compass up to 1, and will draw a line here and here, then extend to 2 and draw here and here, then extend to 3 and 4, 5, 6, etc., and run such lines. So here you can see point 1 achieved, point 2 achieved, point 3 achieved, point 4 achieved, and so on. Joining these lines we will get a parabola. Now coming towards the third part of conic sections, that is hyperbola. First we will construct a hyperbola through a point of known coordinates. Here I draw two axes, that is y-axis and x-axis, from 0 to the point, take a distance 40 millimeter, and again 30 millimeter on the horizontal plane. Joining both these points will give us a point P. Now divide this distance from P to the baseline or to the horizontal line. Here you can see that I have divided it in 3 equal parts. Also the parallel line to the x-axis in equal parts, that is 1, 2. Now extend the line from P to any other x. You can see from the origin erect lines that will pass from 1 to point 1 and point 2 and point 3, etc., and same from 1 to, name here 1 2 3, 1 2. Now draw perpendicular from 1, same from 2, and same from 3. Join this 3 with this 2 with this, and 1 with 1. And here you will also follow the same procedure, 1 to 1 and 2 to 2. Joining these points, we will get a hyperbola with the known coordinates. The second method, that is pressure volume diagram. Here the question is given that if we have pressure of 10, 5, 4, 2.5, 2 and 1, what will be the volume? So if the pressure is 10, the volume will be 1, the volume will be, if the pressure will be 5, the volume will be 2, if the pressure is 4, the volume will be 2.5, and if the pressure is 2.5, the volume will be 4, and so on. And the last, it says if the pressure value is equal to 1, so the volume will be 10. However, you can see that the value will remain constant, that is 10. Taking pressure and volume on two opposite sides or axis, here 1 to 10 and on the other side 1 to 10. Volume increases from left to right and pressure increases from down to top. If the pressure value is 10, volume will be 1. If pressure value is 5, volume will be 2. If pressure value is 4, volume will be 2.5. If pressure is 2.5, volume will be 4. If pressure is 2, volume will be 5. If pressure is 1, volume will be 10. So joining these points will give us these are the points that received uh, from combining or intersecting the lines. Now draw an arc crossing through these points will give us a hyperbola by pressure volume diagram. The last method, that is directrix focus method, for hyperbola, same like parabola and ellipse, which includes eccentricity. So I have told you that eccentricity value will always be greater than 1 for uh, hyperbola. Same like in the cases of above two problems, ellipse and parabola. Here for hyperbola, first of all we will draw a line AB, draw another line and take a focus on it and divide it in equal 5 parts. Now we will take vertex here. Why we are taking vertex here? Because it says that the eccentricity value is equal to 3 divided by 2. So from the focus, the points will be 3. So it will lies 3 points away from focus. So vertex will be lying here. Now taking a focus 45 millimeter. A vertex is taking a line from focus that is 45 millimeter and 30 millimeter above. As I have told you that the point lying in between focus and vertex will the ratio will be same for wherever the location of the point is. So here you will see the points that are intersecting the lines on each other. These are the different points that we have achieved. We have from the intersection of these lines. By constructing a line through these points, will give us a hyperbola. This is hyperbola that we have achieved from the directrix focus method. Thank you. I hope you got the lecture. If you have any query, please you can ask a question on the portal, or you can call me on my mobile, and you can also ask a question through my email. Thank you. Assalamu alaikum warahmatullah.